Welcome back once more again to my YouTube channel. We're still under clashes, right? This is Fluid Mechanics N6. Today we'll be looking at example 1.3, which is a single plate clash. So please subscribe to my YouTube channel and click that notification button so that you'll be notified whenever I post a new video. Stay tuned. Okay, we have example 1.3. Right. Here we have a single clash with both sides has an inside diameter of 220 millimeter. We have the diameter there, and the outside diameter of 420. The axial force, which is FA, there is 15 kilonewtons. The coefficient of friction is 0.5, right? Then it says calculate the following. The question 1 want us the power that a new clash. Take a note. What is important? The new. Must be very careful when you're talking about new. Note there. They've said the new one. New. Like when it is new. Remember, when you're dealing with the new stuff there, you must know that when you're talking about new, which we are under uniform. It's uniform pressure. Uniform pressure theory. Remember, this is new. It's for uniform pressure theory, right? Do not forget that. And can transmit air to a given n there at 1450 reps per minute, right? Okay, that is what we have. So okay, anyway guys, since this is a single, you must know always when it is a single plate, I've talked you about single plate, the number of contact will be 2. Why? I will explain here. If you have a single disc, right? If you have a single or a flash plate, or if you have a single disc or single plate, actually we're used to single plate. We call it single plate clash. If you have a single plate clash, as you can see here it's our plate. I will highlight with another color. Here it's our plate. As you can see, this is our plate, right? That is a plate, right? So we have this plate here. We have a friction surface there. So as you can see, why I say we'll have 2 contact. If you can check, if you apply here, they are, you see those areas. We have pressure. If you apply pressure and there's another area like goes like this, if you apply force, obviously there will be a contact. Check the contact will be a contact between these. There will be a squeezing. Remember, when we apply pressure, we're trying to squeeze this plate. We're trying to squeeze this plate, you see. So there will be a contact there. So as you can see, the contact that will take place here, you see, we're focusing on what? On the plate here, on our plate. How many contact that the plate will experience? Will experience 1, 2 contact. Remember, will be squeezed. Will be squeezed here. There will be force like that. Will experience 2 contact. So that means always when you're dealing with a single plate, the number of contact will be what? 2. Will be 2. There is nothing that you can do there. There will be 2. As you can check, there will be 2. You see, there will be 2. Hopefully you understand there. Then here we are given r, which is the outer radius, then little r, which is the inner radius, as you can check there, right? So in our first story, let's go for question 1. Let us attack question 1. Question 1 there. What do they want? They said we should calculate. They want us to calculate power that a new clash. We are still under a new. This is very important. New clash can transmit, and then we're given n there. So before attacking this question, can just write our data first. Let me just say let us write the data to make our life easier, but we can write data there. Yeah, it's a data given. We have D, which is 220, which is in millimeter. So if we want it to be becoming meter, to divide by 1000, it will simply cost to 0.22 meter. Here it's our diameter. Here was 220. It's a inside diameter, then the outside diameter is 420. Outside diameter is 420. 420 divided by 1000 will be 0.42. This will be in what? Will be meter. Will have meters. So, but we know we are dealing with the radius. You divide by 2. If you divide by 2, this will be 0.21 meter. Then outer radius divide 0.42 divide by 2. We want inner radius here, sorry. If I divide that, it will be 0.11. Obviously this will be 0.21. obviously this is in meter. Remember, it's what we are focusing on. Then we have given what again? We are done. Axial force 15 kilonewton. FA, it is 15 kilonewton. What else we are given? Coefficient of friction. Given coefficient of friction is 0.4. Then coefficient of friction is 0.4. What 5? 0.45. Yes, it is 0.45. But we know the number of contact, because it's a single, we said will always equals to 2 if we are dealing with a single plate clash. So let's answer question 1. We should calculate the power that a new clash can transmit. The power. We know the formula for power. It's equals to 2 pi nt divided by 60, because n is given in rest per minute. If n is given in rest per minute, but if not given in rest per minute, you'll just rubber the 60. But now, because given in rest per minute, you'll simply have to put that 60 there, right? So this is what we have there, multiplied by torque. So for us to get the power, we're supposed to get, if we can find the torque, this we are given, no problem. This is that we are given here on this question. As you can see, they say n we are given. Here it is. So that means here the aim is to calculate the torque. If you can find the torque, then we can get the power. If you can get the torque, then we can get the power. So as we know that torque is equal to coefficient of friction multiplied by axial force multiplied by Rm multiplied by n, number of contact. So we know the problem will be here. Rm, we said it is irrespective the principles. Which principles? The theories. We have two theories. Do not forget, we have two theories. We have uniform wear. Also, we have uniform pressure theory. We have uniform wear and uniform pressure theory. Uniform pressure, we're dealing with a new clash. We are dealing with new clashes. If you have a new and brand new clashes, clash that are not used, then where we are dealing with old clashes, worn, yeah, all those things, second hand clashes, right? So and then uniform pressure our RM, if it's a uniform pressure T, or if the clash is new, will be given by 2 3 R cubed minus R cubed over R squared minus R squared. So that will be RM. RM will be that. So we'll have this when you're dealing with it will be RM. So in such a case, RM will be 2 over 3. What is R? The radius, outer radius. Here is 0,21. Here you have 0,21 cubed minus the inner radius, which is 0, here it is 0, 11, 0, 11 cubed, right? Then here we have 0,21 squared. At the bottom you square these values like this. Then our RM, when you punch this, will simply equals to what? If I punch would be 0,165 meter. Right, we have this 0,165 meters. So in other words, we have this, right? That is what we have. Damn. So enough for stories. Now we know that torque, as you can see, torque is given by that nu multiplied by FA multiplied by RM multiplied by N. Then let us substitute coefficient of friction we are given, which was 0,45. I still remember it, multiplied by FA. Now are we given? We are given Asial. Let me not go there. Here it's our data. It's 15 kilonewton. It's 15. Just say 15 multiplied by 10 to the power of 3. Right. Then multiply this by RM, which is we know is 0,165 because is uniform pressure. Number of contact will be 2, is a single plate. Then punch this. They're supposed to get that torque will be 27,5 Newton meter. It's our torque. We have the torque. Now we can simply calculate the power straightforwards. Power either way. Then we know that power is 2 pi. Power is equal to 2 pi, right? N over 60. Then torque them. Then we'll have 2 pi. This is 114. We'll write 1 forward 50 here. On the weights our that here it is. We do not draw. We are given here on the question, and here it is. Here we have 50. Then multiply by the torque. We have just calculated it there. Divide this by 60. Then power will be, if you want power, then punch this. If we punch that, the power, supposed to have power, will be 338,231,719 watts. Is measured in watts, right? Or this, you know, watts is joules per second, so measured in watts. Then power is equal, then I can divide this by 1000. If I divide this by 1000, I will get this to be 33 8,232 will be in kilowatts now. Then is the power. We're done with the power. This is 338,232 kilowatts. That is power. So number 2. Number 2 says calculate the reduction spring force if each surface of the clutch plate has one. The reduction in spring force. I said we will discuss about this problem. If you have watched my introduction, I've talked about the certain formula. This one, change in Fs. The formula for changing spring. Remember, now it's 1. There must be a change. It will be a change. The reduction is the change. Simply, when I talk about the reduction spring force, reduction in spring force is the change. Reduction. Do not forget this. Reduction will be the change. That will be a reduction. Reduction in change in spring. If each surface of the clutch is 1, this will be change in spring. Change in spring force. So yeah. So if we can calculate the change, we want this. And then I've said this is equal to, okay, here we'll have 2 there. Change in the spring. I said this will be equals to total wear. Will be total wear, guys. Multiply this by stiffness. And multiply this by the number of springs. You see, I write it in full so that you'll know this number of springs. Number of springs there. Number of spring parts. Now, there's something you must know. But total wear, it singularly, it has its own formula. But total wear, it has its own formula, which is total wear. To calculate only total wear, you calculate it separate if you are not given total wear. It's equal, so you must know the total wear formula is equals to the number of contact and multiply by wear per surface. Wear per surface. So this is total wear if you are not given it directly, but total wear, it has its own formula. It's equal to this. That is a total wear. Total wear is equal to number of contact multiplied by wear per surface, right? So let us calculate. Let's check. We are not given that there. We are not given that. Are we given that? Let's read. Say if the clutch is worn, away by 4 millimeter away by 4 millimeter, and there are 6 springs. The number of spring. Maybe let me just do like this and erase here so that you'll see. You see, 1 away by 4 millimeter. 4 millimeter. That 4 away by 4 millimeter, right? So if each surface of the clutch has 1 by 4 millimeter, that is the number of wear per surface. Wear per surface. Read. If each frictional face of the clutch has 1 away by, remember that is what it's wear per surface. You must know that is wear per surface, which will be 4 millimeter. Wear per surface will be 4 millimeter. then the number of spring, and then each spring has a stiffness, a given stiffness, 55 Newton per millimeter, right? So let us calculate that. So here, this the number of shoes, we know it's what is 2, because we're dealing with a single, not the number of shoes. So the number of contact, this is not a centrifugal. We don't have the number of shoes here on the friction guidance. Friction clash, we don't have a number of shoes. I mean, number of contact is 2, because we're dealing with what, if you have a single plate, always the number of contact would be 2. We've discussed about that. Multiply by wear per surface, it was 4 millimeter. It was 4 millimeter. That means this will be 8 millimeters. This will be 8 millimeters. Right? Why I did not convert these millimeters? Because also you can check that the stiffness is also, it's in millimeter. So I'm on the right track there. So right, remember that it's only because you are not given directly the total wear. It's simply just the total wear. This, we've calculated that total wear. This is a simply total wear. There's simply a total wear. So we have the total wear. Now we can substitute. We know that the change in spring force, we know that we said it's a total wear multiplied by stiffness multiplied by number of springs. So total wear, we found that this is what we got, 8 millimeter. It is 8, right? It's 8 millimeter. You must know why I said this will be 8 multiplied by stiffness, whereby the stiffness we've given to become what was stiffness, the 55 millimeter. It was 55 newtons per millimeter. So as you can see, 8 millimeter multiplied by 55 newtons per millimeter. These millimeters will cancel, which is nice. We'll be left with this newton. Yeah, that is why I made that to be like that. So this is nice. We'll simply multiply by 55, multiply by number of spring. They said 6. We have 6 number of spring. Then the change in Fs, you multiply that, multiply this, 8 times 55 times 6, supposed to get this to be 2640 Newton. Yes, you can see there. You can punch that, 8 times 55 times 6. See, that will be Newton. Simply just Newton. It's a force, isn't it? Changing for spring. Then, yeah, we got that. So we're done with this number 2. So the power now says calculate the power that a 1, you must be very careful now, 1 clash can transmit. You see, first we used, it was new, now it's 1. Now this is a uniform wear theory. We're dealing with the wear theory there. This will be uniform wear theory. The power that the 1 clash can transmit, must be very, very careful. Very, 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 very careful. Then number 3 there, must be very careful. We'll use uniform wear theory because you have 1. You said to have 1. Then we'll use uniform wear theory there. So uniform wear theory is what we will use there. So must be very careful. Okay, it's fine. Then we know that power actually is 2 pi, isn't it? Is 2 pi n t. That's what I know. I'll write over 60. So simply want the torque. Cannot calculate it without finding a torque. Must have a torque. Are we given n? The number n. Where is n here? Yeah, n is here at the this paper. The moment, okay, we have given n, we're still using this n, where the n is still the same, just only change just this the clash. Now it's a one, it's an old clash, or it's a one clash, second hand stuff, or damaged clash. That one is surely the damaged one. But it's, uniform wear theory. We're not talking about uniform wear, we're talking about old clash, used clash, second hand, worn, all those things. So yeah, then what about torque? We know it's coefficient of friction multiplied by axial force, right? Multiplied by Rm multiplied by the number of contact surface. So, but we don't have Fn. If I check axial force, we want axial force for one. You cannot use this one. You must be very careful. You cannot use you cannot use the one that you have given, the axial, that available one, because you're supposed to find the axial when the spring is one. Or if you can check previously, if a spring force, the clash was one. The clash was one. If you can find the force, axial force, when the clash is one, what will be the axial force if the clash is one? So how can we find that? Remember, I said, I've discussed about this first. I said, do you remember this formula that I've told you? Remember, I've said, do you remember this formula that says Fn when you're dealing with this single plate? Remember, dealing with what here? With single plate clash, and right? Remember, I've said Fn will be equal to axial force, right? Will be equal also to Fs. But now, if it is a what? New clash. If it is a new clash, that means you're talking about if it's a new under uniform way, if it's a new. But if there is where that occurred or taken place, if there is a where, now you must know if there is a where, only Fn will be equal to Fa. If there is a under one, can say one clash or wet clash will have this, or old clash. But new clash, this, the spring is still new, still fine. It has not damaged. Remember, the spring, the more times goes by, this spring will elongate, this spring will get tired, will be worn, can never be equal to normal force, can never equal to these two. But if it is new, everything will be balanced. If it is new clash, this is what the formula will have. But if it is one, it will be like that. But now remember, they say one. They've told us here one clash. Then we know that if it's a one clash, it's only apply Fn is equal to Fa only. Only note must be like this. Do not include Fs like that. So now we know that is equal to that. So how can we relate? But my question is this: how can you relate? But as this is not a change, it's Fs. But as previously we've calculated Fs, how can we relate? Which formula will allow us to find Fa when we have given a change, not directly Fs, but the change in spring? Okay, Here is the formula for you guys. Here is the formula for you guys. Here is the formula. I have nice formula for you. Here is the formula. Want to use, you want that this thing F. So the formula that we'll use will be normal force will be equal to Fa, but now minus the change in F as the clash is 1. Here is the formula that we'll have. Here is this formula. Normal force is equal to axial force minus the change in the reduction spring, or change in a one spring, right, or a change in a spring force, right? So if we have this, we know that we'll have Fn is equal. Are we having axial? My question is that, do we have? Yes, we'll use that one when it was still new. It was 15 times 10 to the power of 3, right? Minus, now it is 1. There's a change there, which is, we have calculated it. This one, where it is change in Fs in the spring. Here it is there. We got that it was 2640 there, 2640. This is what we have now, right? Then Fn, when you multiply this, what will you get? Punch it on your calculator. Supposed to get that. This is 177. Oh my god, 77 9,84. Oh, this is wrong. Cannot be. Also, I've punched wrong. Why? This will be what? What that can be will be 1, 2, 3, 6 Newton. Yeah, I can double check. Minus 264. Yeah, this is what you'll have. It's Fn, but I've said if it is a 1, Fn is equal to axial. Here I've explained that, but if you are dealing with a 1, normal force is equal to Fa. So it's clearly that, therefore Fn is equal to Fa, whereby all this is equal to 236 Newton. So these things are the same. So we have Fa now. So now we can use our formula of the torque coefficient of friction multiplied by Fa by this coefficient of friction. Here 0.45 multiply the axial they've calculated, which is equal to the normal force 60. What about now Rm? It's 1. If it is 1, now we'll use uniform wear theory. Rm is equal to Rf under uniform wear theory, which is, this is the same as R plus R over 2. Note, this is a uniform wear theory, uniform pressure wear theory. Uniform wear theory, then we have a uniform pressure theory. This is uniform wear theory, right? So you have this uniform wear. This is what should have there, what I'm doing there. Yeah, so we know that will be simply just R plus R over 2. It's what small r there like this. So you can simply just, or you can use it separate. You can say rf r plus r over 2. You put your, what was your, our r, it was 0,21 plus 0,11 divided by 2. This is equal to 0,16 m, 1,06 meter. So we can simply substitute that. Now we know that this is simply equal to 0,16, right, multiply by 2. Remember, because the single plate, number of contacts will be 2 there. If you punch this, our torque will be equals to what? 1779,84 Newton per meter. Newton meter, not per, Newton meter. So this is what we have, Newton meter. This is what we have here for now. So since you have a torque, we can calculate the power. Simply know power is equal to pi nt over 60, whereby this is 2 pi. Our n, it was 1450, the one that we know. Torque is 1779,884 divided by 60. Then if you punch this, find out what will be the power. Oh, is 270,257,393 watts. Right, watts. I'll simply divide this by 1000 if I like. If you like, you can divide this by 1000. Then you'll get that your power, if you divide that by 1000, power simply equals to 270,257 kilowatts. So this was the last question, guys. So thank you guys for watching. Please want some more, do not forget to subscribe. Right, don't forget to subscribe to my YouTube channel and click that notification button and stay tuned. Thank you guys for your time. Thank you guys. You can share this to your fellow classmates. Yeah, you can comment and like. Please help me guys to grow this YouTube channel so that I will help other students. Remember, if you have done with N6, there will still be other students who will need this to watch this video. So if you help me by subscribing, you give me more energy to post some more videos, guys. Thank you guys for your time. All the best.